Hey gang, welcome back. And as promised, we repealed Prohibition. Back in January, we published Repurposed on Purpose, where we turned a 70s style VTR into a digital audio recorder and player, handling PCM and DTS. Yes, full 5.1 surround sound. Well, now we're going deeper. You're about to see how I and you can modify a Sony PCM-601, that old digital audio processor, and get it to pass Spdif DTS bitstreams to composite video. Why? So you can record that digital audio as video straight to tape on any analog video recorder. Now, this mod is straight up off the beaten trail. We're talking jumpers, signal rerouting, a few friendly negotiations between IC chips, and yes, some digital copy prohibition resistance, because as we all know,
resistance is futile.
Let's just say we're giving the machine a little nudge in the right direction. A quick heads up, this is for educational and archival purposes. We're presenting legacy tech in a way that gently persuades it to live up to its potential. So what are you going to need? Well, a Sony PCM-601 would be nice. A soldering iron, jumper wire, a digital multimeter, and although optional, but incredibly helpful, is an oscilloscope or even a logic analyzer. And most importantly, patience. Lots of it. We're going to trace the Spdif copy prohibition bit, identify the gatekeepers enforcing copy prohibition, and reroute critical traces between ICs to bypass those digital constraints. Prohibited and imprisoned DTS and PCM are about to walk free on a technicality. And the escape route? A viable composite video signal. We'll show you where the test points are, where to cut, where to solder, and how to verify that repealed bit stream. Oh, and if you're thinking, wait, why composite? Well, it's not just video, it's a carrier. The DTS doesn't care how it gets there as long as it gets there unimpeded. According to everything I've been able to dig up, there aren't many PCM-601s floating around anymore. But if you've got one in a closet or in a junk bin, or you picked one up at a swap meet, or you've even got that soldering itch, this episode's definitely for you. Let's do this. Roll it. Now that I've got this unbuttoned, we're going to be able to actually take some readings. When you send a digital signal into this Sony machine, then because Spdif, which is Sony Philips digital interface format, there's one little bit hanging out there. And if that tape was recorded, say a DAT tape, was recorded with the copy prohibition bit present, then any Sony device that you hook it up to is going to be looking for that Spdif information, and it's going to see that copy prohibition bit. The 601 is the only one that actually has the Spdif input on it. It actually has a Spdif output as well. They don't want you to be able to make a digital copy for reasons that we won't go into in this forum. I want to be able to take a Spdif signal into this machine and have the video come out so that I can record it. Now, why would I want to do that? Okay, the 701 that I have in my music theater, you feed it analog audio, 2 channels, left and right. Video comes out, you record that on a VTR, ooh, you got something to impress your friends with. If I can use a PCM-601 with the video output going to a VTR from 1970 and record digital stereo audio on it, then I want to also be able to get this to take 6 audio channels to Spdif into this box and spit out the video to my VTR. But I want to take it to the next level. The moment you hook this box up to this box here, all hell breaks loose. What you can see coming out of this box is the PCM encoded video signal. Right now there's no audio present, so what I'm going to do, and I'll just warn you, I don't have any test songs, files that we can actually play much of, but I'm going to hit play and I'm going to force it to mode So there you can see the stereo digital audio, or digital audio, digital stereo audio. I like that better. All right, so there it is on the screen. You can see that it's on the VU meters here, and you don't really see anything as far as copy prohibition going on, which is a good thing. All right, I'm actually going to switch this to analog mode. Now I've taken the analog audio out of that same DAT deck into this PCM, so you're actually seeing, and you might briefly hear it. And that's digital audio coming into the same box, but it's coming in on the Spdif input via this little Chinese miraculous box. That is a 44.1 kilohertz DAT tape with no copy prohibition on it. That's what it looks and sounds like. This is a DAT tape at 44.1 that has copy prohibition on it. We'll take a look and listen to a fraction of this. Okay, the moment that tape loaded up, the screen went blue because the copy prohibition showed up in digital mode, and it's not going to let anything through. Okay, because the moment that copy prohibition bit showed up in the bitstream audio, it basically told this thing, you can't pass that digital signal. It's not going to show up at the output, and my little encoder here turns the screen blue. It still has audio. I can hook speakers up to the output of this. In fact, you can actually hear it. Not too much. I can go to analog, and the analog audio out of that DAT deck going into here is going to show up on the VU meters. And by going to analog mode, the actual PCM information shows up on the screen. Because Sony had convinced themselves that, you know what, if the consumer is going to simply stay in analog mode, then we really don't have to worry about it being a bit-for-bit copy of copywritten material. That's fine. I'll hit stop. I'll basically eject the tape, and the copy prohibition goes away. With this interface box, I'm going to take this signal off of here, which the moment I do, there's no more digital signal going into this PCM-601. The moment I plug this in to this creative box, which is going to have the Spdif encoding in there, listen carefully. All right, don't know if you can hear that, but you can hear a bunch of relays clicking because it says, whoa, Spdif, timeout, no can do. That's how the PCM-601 operates. Now I want to show you some in the weeds kind of stuff. I've done a little bit of preliminary homework, if that's a thing. TP5. All right. Well, TP5 is down here on this board here. I'm going to call this board 4 because by and large, the chips that are on here are IC 401, 402, 403. This board here that I have flipped up out of the way, I'm going to call that board 5 because by and large, the chips on here are IC 501, 502, 503, and so on. But TP5 down here is coming right off of the first, basically the demultiplexer chip that is in this digital section. Right there is what we're going to call high. The bulk of the electronics that are in here are what could be construed as TTL, which goes back a long ways, but TTL, which is transistor logic. Now, I will be honest, there's much more elaborate circuitry in here, CMOS and so on, but it's all really based on TTL. There's going to be a high state at 5 volts and a low state ground. So right now, my scope is showing me that TP5 is at 5 volts, okay? But that's because I am plugged into this box right here, but there's really no tape playing, so the digital information is really not appearing at the Spdif input. In the absence of an actual signal, the scope is telling me that the input on TP5 is low. I'm going to hit play, and it stays low, okay? I'm going to pull this connector off, and TP5 goes high. Plug this back in, TP5 goes low. What that TP5 test point is basically telling me is that the circuitry, the digital circuitry, is acknowledging the presence of a digital signal, doesn't care what's in the digital stream, it just says, hey, it's a digital signal, TP5 goes low.
Hey,
Digital. Digital.
Up yours, you son of a bitch! You don't talk me that way. Get out of here!
And so long as TP5 is low, the digital signal is being acknowledged, but copy prohibition has been engaged. Now, moving on, okay, we are going to go to board 5, and we're going to be looking at IC 508, pin 25. IC London, IC France, and IC pin 25. Now, pin 25 of IC 508 has more to do with copy prohibition than it does for just the simple presence of a digital signal. So let's try this DAC tape with no copy prohibition. So now we have a digital signal present, but the scope monitoring pin 25 of IC 508 is still high state. And everything is working right now because there's no copy prohibition on there. The moment that I pull this cable off, the chassis switches to analog mode, okay? It's looking for a digital signal, but it doesn't have one. But the moment I plug this into this box while that's playing, okay, all hell breaks loose because this box generating a copy prohibition bit in the Spdif mode has caused everything downstream to switch out to prevent you from being able to get a digital signal out of this chassis when you've got a Spdif signal going in. And that's what we're going to fix. Now, in addition to pin 25 of IC 508, there are a couple more chips in here that are doing pretty much the same thing. There is going to be some additional switching going on and some other signals that are going to be sent downstream, and they're going to change state based on the copy prohibition bit. I'm going to go back to the DAT deck with no copy prohibition, and now I want to take a look at another chip. And in this particular case, this is IC 413, pin 12. And that signal is high because, again, there's no copy prohibition activated at this time. But pull off of the interface box and go to Spdif, and all bets are off because that needs to be in a high state in order for it to pass a digital signal and effectively defeat the copy prohibition. Okay. In addition to that, IC 408 pin 26. Well, 408's right next to it, and pin 26 is high. Okay, in the non-copy prohibition mode. I have audio, I've got an output, it's a beautiful thing, but go to Spdif, it's already low, and it stays low because the copy prohibition is there. So this actual output, because it has the absence of a copy prohibition bit, it's in the high state. In summation, these states have got to be held to their non-copy prohibition states. Okay, so in the case of 508 pin 25, it has to remain high. IC 413 pin 12 needs to remain high, and IC 408 pin 26 needs to be remaining high. Okay, and if you wonder what I'm looking at off camera over here, I created a truth table for the states of those pins on those ICs for either copy prohibition or pass-through. Now, to get the downstream circuitry, the copy prohibition circuitry, to ignore the conditions of the copy prohibition bit in the bitstream audio, we have to lock those states into a mode of, oh, okay, it's okay to do this, all right? Using the truth table that I had created here, all I'm going to do is interrupt the foil runs of those particular pins coming from a particular chip that would be sending a signal downstream to cause a switch to occur. I'm going to start with board 5. I'm looking for pin 25. I'm going to lift the foil of that pin and then take the next solder joint and tie that to the 5-volt pin of that chip, which in this case is pin 42. So I'm going to open up the foil run and tie pin 42 to the next solder joint downstream. let's go ahead and just check, make sure we've got continuity now, and then we'll check for no continuity when I'm done. All right, continuity. 508, 22, 3, 4, 5. Okay, I've got 38K, which means that it's no longer a dead short. The foil run is open, but I do want to clean it up. It's going to be held high. I'm going to use red jacketed wire to tie that to the 5-volt supply voltage. So pin 42 is right up here. So I'm going to tie this point right here. I'm going to tie that on to pin 42, which will hold that point in a high state. So that is IC508 modification held high despite a copy prohibition bit. Now to the IC413, which is down here, which means I've got to pull that board up and out in order to get to the underside. Now that I've pulled out board 4, IC413, which is right here, and down here is pin 16. I'm looking for pin 12, okay? This chip, IC413, is a quad bilateral switch. So when the demodulator spits out the copy prohibition bit, IC413 gets a signal and all of those 4 switches switch, okay? And the input to that switch on pin 13 is actually coming from IC408 pin 26. So I need that switch to not send that prohibition signal further on. The other side of that switch is simply tied to 5 volts going to that particular chip. So in a normal mode where copy prohibition isn't a factor, the high signal, the 5 volts, is actually coming off of pin 12. But the moment that the demodulator senses that copy prohibition bit, that bilateral switch gets a signal, and that switch then goes to pin 13, which is coming off of 408 pin 26. Confused? Sorry. But nonetheless, what I want to do is I want to let the switch just continue to do its thing, but I don't want that low signal, which would be for copy prohibition, to be sent on, which goes to IC414, IC501 pin 7, and IC503, which is a digital RAM. So I want to keep that signal high. I'm going to tie that to 5 volts. 16, 15, 14, 13, 12. Okay, yep, and that still comes down to CNP3. It's just a connector that goes to someplace else. All right, but I need that to remain high. So this point right here, once I interrupt that foil run to pin 12, I'm simply going to tie it somewhere along in here, because this is the 5 volt supply to that chip. Now there's a lot of foil runs here that are running very parallel to that, and it gets really crowded. So I'm looking for a spot where I can interrupt that foil run without necessarily affecting, quote unquote, the foil runs that are adjacent to it, because these rivers and streams of foil runs run very close together. I'm going to go ahead and score that, just rubbing some of that greenish off of there so that I can see the copper underneath. Just scoring it in the same place every time, going a little deeper each time. I want to check the continuity, make sure that it is in fact no longer connected across that foil run. And I've got 27K. So that looks to me to be interrupted. Now I want to look around and make sure that any of that copper foil didn't crumble or is just laying around on there. I want to make sure that I've cleaned all of that off. I don't need that piece of copper foil now floating around inside this chassis. And I got it. That right there could cause a problem later on. So everything downstream from IC 413 pin 12 is not going to see the output of that switch just now. So IC 413, 16, 15, 14, 13, 12, and coming off of pin 12 is a foil run that has now been interrupted. It no longer can travel all the way down here to CNP 3. So at this point, we now take CNP3's pin, which is supposed to be sending that signal onto IC 414, IC 501 pin 7, and IC 503. Yeah, and IC 414 is right over here. I can go to various pins on IC 414 and see that it's going to be making a run back to that switch, but doesn't work no more. And I don't need much because I'm not going to go very far with it because there's 5 volts present on that chip, IC 414. So I'm just going to use that 5 volts to take that connection to 5 volts. I'm going to hold that wire in place. The 5 volt source, which is going to pin 16, the first thing this pin does on 16 is it goes to here. This is a jumper, which is basically taking the 5 volt source, which is actually down here. I can use a very, very short wire to go from here to here, but the wire is going to be so short that it's going to be unmanageable. So I'm going to go to the next nearest spot, which in a direct line would be from this point here of this connector down here, where it's attached with a jumper and so forth. So I want to just basically come from this point down to this point here. Okay, not this point because that's the other side of a capacitor, which is underneath there. This side of that connector, now interrupted from pin 12, is now held at 5 volts. Pin 12 is now high, which ought to make him really fun to be around. I'll be honest, I think I'm ready to put some juice to this and see how it behaves, see if my guesses were even in the ballpark. So we'll do that next. Well, so far so good. What I want to do is simply duplicate all of the steps that I went through prior to the modification. So I'm going to start with a DAT tape with no copy prohibition on it and hitting play. Digital mode, analog mode. One thing I'm noticing is that the digital light no longer comes on. Let's test that theory. But that, crap, that's why. The digital interface is not connected. I do have a digital light here, which means that this unit is seeing the interface box from the portable DAT deck. All right, so that much is working. Let's confirm that it's operating in digital mode. And I'm going to disconnect the audio speakers. I've got a digital input. I'm going to pull the digital input to the deck to see if it switches over to analog. And it does. And I'm going to pull the left input channel, and there it is. So it does switch to analog, reconnecting the digital input. Relays click. I'm in digital mode. I've got a digital light, and it's playing back a digital tape with no copy prohibition. So now let's try a tape that does have copy prohibition on it. Now, the moment it would load up, it would give us the copy prohibition light. Okay, but it hasn't done that yet. So let's go ahead and hit play on the tape. Okay, No copy prohibition. I'm going to pull the digital input, listen for the relays. Okay, and now I am in analog mode. Going back to digital input, the relays will click. Okay, and I am in digital mode with no copy prohibition from a tape with the copy prohibition bit on there. Now, next test is going to be taking the output of this I/O box. The digital goes away, but I'm going to hook it up to this Spdif output box that we talked about, and it has switched to digital mode, but I have no audio present. It's because there's nothing going into it right now. No copy prohibition that we had before because it was coming out of the Spdif box. Let's take and feed this tape that I'm playing into this box on just the two front audio channels to see whether or not I actually have a signal visible from the video output of the chassis. Front channels. And what I have is a Spdif signal, which looks like it's just noise. But what I do have is a signal on the VU meters, which again is just bitstream audio, discrete 5.1 bitstream audio. So all it's going to be is noise, but it is in fact digital audio. The beautiful thing is that there is no copy prohibition, and there is digital audio coming out as a composite video signal that can be recorded on a VTR, which is what we set out to do. Cool, huh? So now that we've got that much out of the way, let's go ahead and just confirm that the modifications are doing what I intended them to do. And the best way to do that is to just go ahead and grab the scope and check. Now, I've got a DAT tape in the portable deck with copy prohibition on it. So we want to monitor how the pins on the chips are behaving. IC508 pin 25, which is C22, 3, 4, pin 25 is high. Typically with prohibition, that would go low. Okay, so let's go ahead and play a tape with copy prohibition on it. 22, 3, 4, 5. Pin 25 is high. And the modification, of course, is going to remain high. All right. But that is remaining high. So this is a tape without copy prohibition, and that is also high. So this chip is ignoring the copy prohibition because copy prohibition would have sent pin 25 low, and it is high. Let's come on down here to IC413 pin 12. All right, well, that's high. So we'll try a different tape, okay? And I'm going to go back to pin 12 before I actually load that tape up. So 9, 10, 11, 12, okay? Load the tape up, and it goes low. But the connection that it was going to is now held high, which defeats the copy prohibition. Also, 408 pin 26, which is right here, is low. But if I hit the stop button, I'm going to even go so far as to unload the tape. 408 pin 26 goes high. That's because the tape is not actually telling the circuitry to turn it off. So pin 26 is high, but the moment you put a copy prohibition tape in there, it goes low. But where that's supposedly going to has been modified because that chip is actually feeding chip 413, right? But that's been modified to be held high. So the prohibition has been repealed. I've got mine. Now it's up to you. 5.1 surround sound from a Retrotech videotape deck. Who would have thought we'd be rolling digital audio straight to composite like it was smuggled past the audio authorities? Tackle this project and let us know how you manage in the comments. And hey, I've got the cheat sheets. A quick tech tip. I used bus wire to tie the pin straight to 5 volts to prove the concept. But listen, TTL chips usually don't have current limiting resistors, so if you're following along at home, do yourself a favor and use a 1K resistor between the jumper and the 5-volt rail. It'll work either way, and your chips will thank you. If you missed our January episode, Repurposed on Purpose, check it out for the full backstory behind this whole digital jailbreak. Cool? Give us a like. And if you're feeling frisky, hit the subscribe button and ring the bell. Thanks for supporting us on Patreon and for your time this time. Till next time, be well.